Welcome to qnawire.
Our question says that it wants us to look at figure 9-60, where car A has 1,100 kilograms, I write that as M sub A, and stops at a traffic light where it's rear-ended by car B, which has a mass of 1,400 kilograms, M sub B. Both cars then slide with locked wheels until the frictionless force from sliding on the road, which has a coefficient of friction, U sub K, or mu sub K, 0.13, stops the car A, dA, at a distance of 8.2 meters, and car B, D sub B, at a distance of 6.1 meters. What are the speeds of car A and B at the start of the sliding, just after the collision? And then C, assuming that linear momentum is conserved during the collision, find the speed of car B just before the collision. And then for part D, explain why this assumption may be invalid. Okay, well, we can go ahead and first we need to calculate the acceleration of these cars, which is equal to the force divided by the mass. So this would be the deceleration. Well, the force is equal to the coefficient of friction, U sub K, times the mass, times gravity. Because that's the force acting down essentially from the weight of the car. Then you also are dividing by mass. Well, the masses cancel out, and the acceleration here is mu sub K times gravity. Okay. Well, we can also use the equation that says V squared is equal to V naught squared plus 2 times the acceleration times the distance. Well, in our case, this is just equal to 0. So this simplifies to 2AD, but we just said acceleration is mu K times gravity times D. Therefore, V is equal to the square root of 2 times the coefficient of friction times gravity times the distance. Okay, so for part A, the velocity V of A squared, V of A has to be equal to, so the square root, 2, and then in our case, we'll use mu of K of 0.13. Gravity is the same in both cases. And then in this case, we have D sub A, which is 8.2 meters. Plug those values into this relationship, and this comes out to be 4.6 meters per second. So we can box that in as our solution to part A. Okay. For part B, we just simply do the exact same thing, except we substitute in the distance that car B travels. Do that on this page. Part B. So V sub B is going to be equal to the square root of 2 times the coefficient of friction times the acceleration of gravity, and this time, distance of car B. Plug those values into this expression, and it comes out to be 3.9 units meters per second. And box that into our solution to part B. Now part C, we can use the conservation of momentum, which says that because initially car A is at rest, so the initial velocity of A is 0. So that means the initial momentum of A is 0. But the initial momentum of B is VB times the initial velocity of B, which is going to be equal to the final momentum, which is just mass of A times the velocity of A, which we calculated in part A, plus the mass of B times the velocity of B, which we calculated in part B. So the initial velocity of B is equal to MAVA plus MBVB divided by the mass of car B. Plug all those values into this expression, and it comes out to be 7.5 meters per second for the initial velocity of car B. Okay. Now for part D, we're asked to explain why this assumption may be invalid. Okay, so I think it's better for me to just kind of explain it, and then you can maybe put it into your own words. So the conservation of linear momentum during the impact is going to depend on the fact that the only significant force during the impact time duration is the force of contact between the two vehicles here. So in this case, this implies that the force of friction exerted by the road on the cars is neglected during this time interval. And this neglect would introduce some errors in the analysis. Related to this assumption, we are making that the transfer of momentum occurs at one location, that the cars do not slide appreciably during that amount of time, which is certainly an approximation. Though it might be a good one, it's still an approximation. And then another source of error is the application of the friction. You can look at this relationship in equation 6-2 from the sliding